The discovery that changed science forever did not happen in a palace. It did not happen in a classroom. It did not even happen at a desk. It happened in a bathtub. And the man who made that discovery ran through the streets, half-dressed, shouting a single word at the top of his voice. Eureka! I have found it. This is the story of Archimedes' end, the moment that taught humanity how to measure truth itself. Long before modern laboratories and precision instruments, the ancient world was driven by a different kind of question. Not how fast, not how big, but
how true?
In the 3rd century BCE, the city of Syracuse stood as one of the great centers of Greek civilization. It was a place of power, wealth, and political intrigue. At its heart ruled King Hiero, a practical man, proud of his city and cautious of deception. One day, the king faced a problem that seemed simple, yet impossible. He had ordered a crown made of pure gold, intended as an offering to the gods. The goldsmith delivered a beautifully crafted crown, shining and flawless. But the king had a suspicion. What if the goldsmith had cheated? What if some of the gold had been secretly replaced with cheaper silver? The king could not destroy the crown, it was sacred. He could not scrape it. Its form mattered, and he could not rely on appearance. Silver can hide inside gold. So he turned to the greatest mind of his time, Archimedes. Archimedes was not a man of politics. He cared little for power or wealth. He lived for ideas. Born in Syracuse, he studied mathematics, geometry, astronomy, and mechanics. He believed that the universe followed laws and that those laws could be understood. To Archimedes, numbers were not symbols, they were truths waiting to be uncovered. When King Hiero presented the problem, Archimedes accepted, but soon realized its difficulty. How do you determine whether two objects of identical weight are made of different materials without damaging them? Gold and silver weigh differently for the same volume. Gold is denser. Silver takes up more space for the same mass. But how could one measure volume of an irregular object like a crown? For days, Archimedes struggled, he thought. He calculated. He failed. Sometimes, the greatest discoveries do not come from effort, but from stillness. One evening, exhausted, Archimedes stepped into a public bath. As he lowered himself into the water, something ordinary happened. The water level rose, but in that moment, Archimedes saw what no one else had seen. He noticed that the amount of water displaced depended on how much of his body entered the bath. Not his weight, not his shape, but his volume. And suddenly, the pieces locked together. If an object is submerged in water, it pushes water out of the way. The volume of water displaced is exactly equal to the volume of the object. And if you know an object's weight and its volume, you can determine its density. And if the density is wrong, the object is not pure. In that instant, the mystery of the crown was solved. Archimedes leaped from the bath. Legend tells us he did not even bother to dress. He ran through the streets of Syracuse, shouting again and again, "Eureka! Eureka! I have found it." This was not madness. It was joy. The joy of understanding. Using this principle, Archimedes compared the crown with a block of pure gold of the same weight. By immersing both in water and measuring how much water each displaced, he could tell whether the crown had a larger volume, and it did, which meant silver had been mixed in. The goldsmith had cheated, but something far greater than royal justice had been achieved. A law of nature had been revealed. This idea became known as Archimedes' principle. An object immersed in a fluid experiences an upward force equal to the weight of the fluid it displaces. This simple insight explains why ships float, why submarines dive, balloons rizzy, and how we measure density. Today it's connected weight, volume, and matter in a way no one had before. Pause for a moment. Where are you watching from? Are you a student, teacher, engineer, or simply curious about science? Comment below, because Archimedes' discovery belongs to all of us. Archimedes went on to make extraordinary contributions. He approximated the value of pi more accurately than anyone before him. He invented war machines to defend Syracuse. He laid foundations for calculus nearly 2,000 years early. And yet, when history remembers him, it remembers a bathtub, because that moment captures something eternal. Discovery does not always come from force. It comes from attention, from noticing the ordinary, from asking better questions, from refusing to accept mystery as final. There is a quiet lesson hidden inside the Eureka story. Archimedes was not searching for water. He was searching for truth. And when truth appeared, he recognized it even in the most unexpected place. That is what makes him timeless. If you enjoy stories like this, where mathematics and science are told through human moments, curiosity, and discovery, subscribe to MathsWhisperer. Here we learn math with stories, not rushed, not mechanical, but alive. In the next episode, we'll explore another surprising question. How did humans learn to measure the impossible? Until then, stay curious.